Now we want to move on to a different measure of position called percentiles. Now we actually saw percentiles a little bit when we dealt with ogives and cumulative relative frequency in chapter 2. So it's the percent of data that are at or below a given value. So let's think about this in terms of a picture. So which I'm drawing down here. So we have a minimum over here on the left. That's the lowest value you ever have. And you have a maximum over here. So if you put your data set in order, right? So if you go from lowest to highest, what you can do is you can divide your data set up into 100 equal parts, where each part has a percent of the data set. There are 99 cutoff values that would divide your data into 100 equal parts. So you have your minimum right here. So right near that, you would have P1, percentile 1. And 1% of your data is below that P1. Then you would have P2 right here. And then another 1% of your data is below there. So together, 2%, right? Because 1% and 1% makes 2%. And you keep going like that. And there's 99 of them to get you all 100 sections. All right, so are there some more important percentiles that we want to think about? Yes, indeed. So there's one in the middle. That'll be P50, right? 50% would be below that value, right? As opposed to P2, which has 2% below. So 50% is below the 50th percentile. And then what's another one? Well, right before that is P49, right after it is P51, right? That's how it works. So another important one would be P25. P25 would have 25% below it, right? There'd be 24 numbers below, 1, 2, 3, 4, right? Each one separates one section off. So this would have 25% below that value. And then over here on the high side, well, half of 50 is 25. So halfway between P50 and the max would be P75, right? Which would have 75% below. And keep in mind, there's other ones in here. So P24 is right there. P26 is right there. Right? P49 is right there, and so on, right? P74 is right there. But the most important ones are P25, P50, P75, the min and the max, right? Those 5 numbers will come back. They're called the 5-number summary, and they're very important. Oh, and right here at the end, right, is P99. Right, P99 is right here because 99% of the data is below, right? Only 1% of the data is above. And that actually is the interpretation. So if you're hearing what I'm saying you have this percent below that value, right? Or K% of the data sets are at or below that value. Either way you want to say it. All right, so let's actually do some interpretations because that becomes key to understanding how to do this. So suppose your child is in the 3rd percentile for weight. Is this cause for concern? So let's start with the interpret piece. So you take your percentile and you turn it into a percent. So in other words, your child is at whatever P3 is. So you'd say 3%. So 3% of, and then what would this be? What would the data values or observations be? It'd be children. So 3% of children are, and you could say less than or equal to your child's weight or at or below your child's weight. Either way you want to say it. Are less than or equal to, and we don't actually know the value here. Sometimes we know it. Sometimes they'll say what the child's weight is. So we could put the value in if we know it. But in this case, we don't know it. So we would say 3% of children are less than or equal to your child's weight. Oop. Whatever that value might be. And is that cause for concern? Yes, generally, your child is in the low percentile, so that could be cause for concern for being underweight, right? Because they're quite low, right? They're on this end of the data set. Okay, suppose you scored a raw score of 63% on an exam, which means you were in the 84th percentile. Was this an exam a difficult one? Did you score well or poorly? Okay, well, let's start with the interpretation. So you take your percentile right here. So this is your percentile, right? Becomes that, right? That's where that comes. So 84th percentile. So you say 84% of, and then you have to put in what the context was, right? What was the data set? So test scores, or exam scores, I should say. 84% of exam scores were less than or equal to your score of 63%, right? Because that's your value, right? The percentile is what makes the percentage, not this. This is just the score. All right, so did you do well? It seems like this was a pretty tough test because most students are well below passing, right? Below 70%. So this would be a difficult test. If 84% of the students scored below a 63, that would be a difficult test. As 84%, so many students are below passing, right? Below a 63. Remember, you need a 70% to pass, at least in this class. Okay, so then suppose you had a raw score of 81 on an exam. Ah, so you passed it, but you were in the 59th percentile. Okay, so 59th percentile, that becomes your percentage. So 59% of exam scores, and I'll use the other script this time, were at or below your value of 81%. Right? Again, sometimes you're given this number, sometimes you're not. Sometimes you just kind of write in words, my score or whatever it is, right? So you could say your score. Right? Sometimes if you're not given the percentage, you could just put that instead. Okay, so did you do well or did you do badly? Right? And was this an easy test or a hard test? Well, this test was easier because a lot of people are, well, think of it this way. 41% are scoring above 81, right? So 41% of the class, not half the class, but a lot of the class scored well above 81. So this was an easy exam. As so many students, well, let's put it this way, as 41% are above a score of 81, right? I forgot to answer the question of how well you did in both of these tests. So let's think about this. So this was a difficult test, and you scored well on it in terms of comparing to other folks because even though you only got a 63, you did better than 84%. So it's a difficult test. And did you score well or poorly? You scored well because you're better than 84% of the other students. Whereas this test, which is an easier test, and you scored an 81, and that's all well and good. I mean, 81's good. It means you passed. But how did you do in relation to the group? Well, the answer is not as well because instead of being better than 84% of the students, you were only better than 59% of the students. You scored not as well. I don't want to say badly because you're still better than half the class, but not as well. Only better than 59% of the students. So you'll notice what I mentioned on the first page, right? It still matters. So it's not always a question of just your raw score. I mean, raw scores are all well and good, but how you feel about the test in relation to everybody else might vary. So this one you didn't pass, but you know you did better than a lot of people, right? And that feels good because then you know you're getting it better than others. Whereas this one you passed, but you didn't do as well in relation to the rest of the group, right? So your measure of position can change how you feel about the score based on how you are in relation to the group. That's what percentiles can do, as as well as z-scores, right? Both of them can give you a sense of your position in relation to the whole.